Hello, thank you for watching this presentation today. My name is Sam Bast,
My name is Komlavi D'Amato.
and today we'll be talking about the research project that we've been learning about and trying to experiment with, which is the Internet of Things and preventive maintenance, while specifically looking at dust and air quality with that preventive maintenance.
So, in our introduction, we have the motivation and objective, literature review, test plan, device and other component, and the discussion. Our motivation and objective, the wireless technology continue to evolve. So, in that particular section, our goal is to be prepared for what is to come. The second is the usage and ease of IoT device. So we focus on the gain first, hands-on experience. And the third is view in IoT use in the industrial setting for the preventive maintenance and air quality monitoring.
So with that, before we get into specifically what we did, we're going to look at our literature review that helped us prepare for this. With that, we have a few main topics. The first of that is IoT, which is specifically the Internet of Things. And for more, maybe not basic, but the definition that is used for it a lot can be seen as the interconnection of things to sense the environment and communicate what is being seen, what is being collected. With that, it can be in a variety of settings. It can be in a factory setting, can be in a smart city, can be viewing traffic. We're trying to collect the data in the environment, send it to a particular sender device that then is going to do something with that data, whether it be collecting it, sending a warning or a message based on the result of that data, or just perhaps displaying it real time. So we're hoping for that interconnection of everything. Particularly though, a key factor of it is that it's wireless. There's no wires, keeping it stuck in a certain area. Perhaps there might be wires in a computer or hooking up sensors to a device, but it should be able to, be implemented wherever it needs to be. With that, there are three main sections that make up an IoT system. There is particularly like a microcontroller that has those sensors that is collecting the data that is wanted to be viewed, like the temperature, humidity, for example. Then we have our wireless network that is, we're having the data be sent over it, and then it's going to a computer portion. This computer portion, can have a broker and then usually has a component that does something with the collected data, whether it be just saving it, whether it be displaying it, or possibly taking an action as mentioned. So with that overall, the goal is, to record the variables displayed in real time and then cause some sort of reaction. The next topic that we're specifically wanting to look at IoT in is that of preventive maintenance. Preventive maintenance can be seen as a system of maintenance where we're trying to be proactive in terms of inspecting and repairing machines. It's usually based off of a predefined schedule or algorithm of some sort that makes that so that we're continuously, watching it and repairing it when it needs to be, ideally before it breaks down. We're not just waiting for it, oh, it breaks down, now we're fixing it. We're trying to be proactive on it. And so with this, usually one needs to collect data on the system or machinery that it's looking at. And then, then from there, they're figuring out patterns in it that then can allow them to do that improved maintenance. With that, it is helpful, but it definitely can be more complex than a normal, wait till it breaks down or other methods. That being, you need to have a dedicated person or system of automation that is watching the system. So with that, if you're just starting it, there can be initial costs to doing it, as well as in terms of keeping it going, that can be cost. But setting it up initially for sure, as well as if you're automating it, which is kind of where IoT would come into play of having that continuous eye on recording data for it. With that, even more specifically, with preventive maintenance, we're looking at air quality. This is a major impact, not just to the machines, but to the workers itself. 90% of bad air quality happens in to individuals, and that is usually where workers are. Most workers are in an inside area. And with that, besides making people sick, it creates clogs in machines. It can make it dirty, as well as just causing jamming of machines. So with that, there are various issues that happen with air quality. One particular one is dust. That's one of the major ones that particularly for air filters. There's also just different pollutants or chemicals, such as CO2. There's sicknesses as well that spread to workers. And then another key thing is just material that's small. And with that small material, if it's small specifically, as seen with PM10 or PM 2.5, which the particular rating that's bad is 20 to 10 micro to the -3. That is when those materials are able to get inside your lungs easily. And so that's a major issue of particulates that you have to watch out for. And so when we're combining it all together, there have been devices that have been used to look at preventive maintenance and air quality with IoT devices. Usually, you're either measuring the air quality or you're looking at filters. It's not usually combined, so ideally we would try to look at those in a combined situation. And with that, the setting that it goes in isn't exactly preventive maintenance and with air quality in general. There's hospitals usually, which makes sense. You don't want people that are sick or could get sick having bad air quality. Construction sites, you'll have a bunch of dust or just, building material or construction material that can get around. Another situation that we looked at for background was freezers. They have to monitor air quality, to ensure that the food doesn't go bad or to detect if food has gone bad. So that's another one. And then there has been some work in factories with preventive maintenance, but not necessarily in the air quality field exactly. And then also looking at all these situations, there have been variety of components that have been used, whether it be Python, Node-RED, Arduino, SQL servers, mosquito brokers, many various sensors. It sort of depends on the specific scenario. But it does show us that it is possible to set up devices that we would want to do for the test that we looked at. It's just a matter of us, having done it and looking at it.
So about the test plan, you have to measure the air quality and capacity of the filter at KCND by using the Arduino, IoT, and various sensor. So about the measure key variable, we have the pressure of filter, the quality of air for particles, the CO2 level, the humidity, temperature of filter and device. And then for the next step, we start with the basic version, only pressure that then expand with more complex version. So we gotta do all that in the evening. For the equation, as you can see on the picture, we have to put the Arduino sensor on the back of the cell. So we have the filter on the picture. So behind the filter, we plan to put the Arduino sensor in that specific area. So our decision is based on the dust concentration, airflow patterns, accessibility, avoidance, obstruction, temperature, and humidity. And the last one is the safety.
So with that, knowing the location and the general idea of what our testing was, we're looking at what our device looks like. Here specifically is more so the wiring. One of the more basic versions is what we we have here, which is that of the the developmental board, MKR Wi-Fi 1010, as well as the BME 280, which allows us to look at that pressure. They already monitor pressure, so that's kind of why we're starting off there. And then humidity and temperature we're also looking at, just because it's built in with that. And also those are key variables, because the higher humidity leads for increased cases of sickness and more dust coming up, as well as just temperature to monitoring if the device is overheating. With this, not necessarily the biggest device, but we have some key sensors. The Adafruit SCD 30 NDIR is measuring the CO2. That's just a specific chemical that can be bad for humans, well, and animals in general, if in large quantities. So that's why we would have that one as well. And then we'd also have our PM 2.5 air quality sensor. That's measuring those small particles. It can read more than just that small, but again, those are the smallest that hurt humans the most with getting into lungs. With that, there are other connections. We'll be using the Arduino IoT cloud specifically for what connects to our dashboard to display the data, but we will get to that in a bit. Looking at our coding, just to get an overall sense of what our coding looks like, this is it, but we'll describe it in a second, the actual more key important parts. But just so you understand and can see what we did, that's it. Looking at the code key points, a key part was using that I2C connection in terms of getting those sensors and wireless connections. With that, there were only two of the sensors that would need the I2C, that being the BME and the SCP3. And fortunately enough, they have two different target addresses, so we wouldn't have to worry about the data that's collected overlapping at all. And the particle sensor doesn't need to do that. That's just using two of the inputs, well, technically one to get the data in. But so we have that, so we don't need to worry about that. It all works out technically fine there in terms of wiring and the coding. More specifically in coding as well. They're all floating variables. We're trying to get them off the functions. Currently, we're not necessarily doing a bunch of math per se to find new intriguing patterns from it. The biggest conversion, as Kamblavi mentioned, is that in pressure, we need to be in I2C. So there's a conversion to that inches to pounds. So we are adjusting that. And the majority of the wireless portion of it is just off of the base Arduino plan. So we're not necessarily completely remaking the wheel. We're just adjusting it more to what our needs are for the situation.
So, as you can see on the dashboard, we are trying to display the pressure and humidity. So from 0 to 5 water inches, that means our filter is okay and is clean. So we don't have to do any maintenance or preventive or anything like that. But behind or above 5 water inches, at that point, we need to change the filter and keep doing our maintenance. So on the bottom of the photo, we have the temperature and humidity as well. All of them are in percentage. So from 0 to 50% mean the filter is clean, and above 15, we need to change our filter and do our maintenance.
So with that, just kind of results of what we wanted to do with this lab. There were good and bad things for it. The good is that the location of where we wanted to put the sensor worked out, it fits. But we did have issues connecting to the Wi-Fi, likely an issue with the firewalls of the company. But we just weren't fortunate enough to gain complete access like we wanted to. But it was nice to know that we could fit it in the area. So with that, future things we would do with that. Well, we should say that we were able to do like tests of the device and sensor at home, and it works and updates to the dashboard. It's just, we can't really, see if it truly works with the filter itself, which is the negative of it. But in the future, ideally we get that better wireless connection. We would try ideally more locations just to see, is this location reading better than other ones? Is it collecting better data? You know what I mean? Something like that. We would also just try different sensors, see if there are other sensors that are better quality, maybe better cost effectiveness as well. To see if, if we were to implement this someplace else, if they have a harder budget, doing something like that. Another thing we'd look at is actions that take place. Right now, we're focusing on just seeing what is happening. We have that part that shows the history. We have another part that's showing right now the value. Is it in the percentage that's good or bad? Actually getting a response. That thing that says, okay, you have to do something, sending an email. So looking at that. And then the last component would be that of seeing what different times of the year, kind of we're in spring right now, getting into summer. How would that affect compared to winter or fall? So just seeing what different types of data we would get.
So in our conclusion, we cover the motivation and objective, literature review, test plan, device and other component, and the discussion.
So thank you for listening to our presentation today. Hopefully you learned more about IoT and particularly the predictive maintenance and air quality factors with it and dust. There's more work that can definitely be done with this, but it's definitely a start. Thank you again for tuning in.
Right.